The first thing we're asked to do here is to find the equation of line L. And what we've got to remember here is that every straight line has equation y equals mx plus c, where m is the gradient of the line and c is the y-intercept, where the line cuts the y-axis. Now, the y-intercept is very easy to find. Here's the y-intercept here. So for this particular equation, c is equal to 4. So I now know that my equation is y equals mx plus 4. The next thing I need to do is find the gradient. So this line I can see has a negative gradient, so it's y equals minus something x plus 4. And to find the gradient, I draw a right-angled triangle underneath the line so that I've got a whole number of squares. Let's do it here, say, and then across. So if I count the number of squares, I've got 2. Check that the scale is correct. So that's 2 units from there to there. It's 4 units from there to there. The gradient then is always rise over tread, or vertical divided by horizontal. So the gradient is 2 over 4, which is a half. But remember, it's negative this time, the gradient. So the equation of my line is y equals minus a half x plus 4. Okay, the next part of the question asks us to look at some inequalities. Now, the first thing that I'm going to realize is that this line here is the same line as this one here. So this line here is y equals minus a half x plus 4. And I need to find the equations of the other two lines. Okay, let's have a look at this one here. This is y equals, now the gradient in this case is 1 divided by 1. So the gradient is actually just 1. So the equation of this line is y equals 1x, well that's just x, plus the intercept is actually just 0. So this is the line y equals x. Let's just get rid of that. And if we look at the third line that we've got here, which forms the boundary to the regions, the x-axis, remember, has equation y equals 0. So lines which go in this direction horizontally are always y equals something. The y-axis, on the other hand, has equation x equals 0. So this line here has equation x equals minus 1 because it passes through minus 1 on the x-axis. Right, let's start having a look at our inequalities then. So, first of all, for y equals x. Now, we've got a choice here. We are looking at the unshaded region here, and let's assume that this side of it, well, let's assume that y is greater than or equal to x, because we're talking about the area which is above this line. Let's assume that we've got y is greater than or equal to x. I'm assuming that the area to the above this line, all this part here, is y is greater than or equal to x. Just to test it, though, I'm going to choose a point which is in my region. So let's say the point 0, 2. So let's test 0, 2 and check whether this inequality is true for the point 0, 2. 0, 2, then y is 2, and is 2 greater than or equal to 0? The answer is yes, so this inequality must be correct. Y is greater than or equal to x is one of them, so I can put that on my dotted on my line below. Okay, now let's have a look at this one. I'm going to assume that because this is the line where y equals minus a half x plus 4, and the region I want is below the line, I'm going to assume that y is less than or equal to minus a half x plus 4. And again, let's choose that point 0, 2. Let's test with 0, 2 again and see whether the coordinates of that point, when I plug them into here, make this true or not. So y is 2, less than or equal to, well, minus a half x is just going to be 0. So is that true or not? Is 2 less than or equal to 4? 4 is bigger than 2? Yeah, that's true. And if that's true, then it means that this inequality must also be true. So there's my second one. Now I look at x equals minus 1. Well, on the line, that's where x is equal to minus 1. It's fairly obvious that to the right of that line, which is what I need, x is going to be greater than or equal to minus 1. So there's my third inequality.